Hello, and welcome to our Interim 1 study tool video. So what I'm going to do is I'm going to go through page 1, so all the things to be covered under Interim 1 on this video for your review. So the first one, and you should probably have, your study tool sheet in reference for this, is what are the types of scientific observations? So the types of scientific observations are quantitative and qualitative. So it's asking you to write those definitions. Now, as a reminder, quantitative is a quantity. So the number that is being observed. So that would be like, I have 14 tables in this room. I have one brother. That would be an example of a quantitative observation. A qualitative observation would be like, my brother is shorter than me. It is sunny outside. It is describing a feature of something. So you'll be asked multiple questions where it's going to give you an observation. And really, the key operational definition there is, did it count something? If it did, it's quantitative. If it didn't count something and is describing something, it's qualitative. The next section is going to be setting up an investigation. The example that I will be using is, does the amount of chocolate that I put into a dessert determine how much people will enjoy the dessert that I make them? So things that I need to control are everything that I have kept the same. Same is the key word there. If you see same, it's a control. So for instance, it wouldn't be fair if I did a pineapple upside down cake and like a chocolate molten lava cake for you to compare them. You'd have to do the same recipe. Same is a control. It also wouldn't be fair if on one of my recipes I made it with milk chocolate and another one I made it with dark chocolate. That wouldn't be fair. So if I was testing what type of chocolate, then that would be a test. But I need to keep it the same. So if I keep the chocolate the same, that is a control. I'm going to keep the recipe the same. I'm going to add the same sugar to both of them. Same is a control. I'm going to add the same amount of flour to both. Same is a control. Everything is going to be controlled except the one thing I am changing. The one thing I'm changing in this is the amount of chocolate, which when you look at that test, does the amount of chocolate affect or determine how much someone enjoyed the dessert I make? So, anyway, I'm going to almost change this right here. Does it affect how much? So we can see that. Uh, the thing that we're testing is, does the amount of chocolate. That is called your independent variable. The one thing you are changing in the experiment is your independent variable. That's the one thing you're focusing on. The only thing you're changing. Everything else should be a control. Finally, how are you going to measure it? Well, in my scenario, it's going to affect, well, how much people enjoy the dessert I make them. How many people are going to like that one more than the other one that has less chocolate? So the thing I am measuring is called your dependent variable or responding variable. In this case, it would be how much people like my dessert. It's the thing you are measuring. How are you proving that the first thing, your independent variable, did anything, that it was affecting anything? The next one is about data collection. How much data is the most important one? So if you remember back to when we flipped a coin, and let's say it was heads, you're not going to make a very good conclusion of whether heads or tails is going to be the right answer by one flip. And then when you did 10 personal flips, some of you got 8 heads, but other people got 8 tails. So that would really determine yours. If you had 8 heads and 2 tails, that's a pretty good conclusion to be like, hey, I think heads comes up more often. But once we as a class had up to 200 plus flips, you started seeing that it was pretty even, but it could still be a little off. But once we added so many flips, you started seeing the real truth. The more data, the better. On the test, it's going to ask you about a plant test. Is it better to have one plant, 10 plants, or 1,000 plants? The more data, the better that is true data that you're taking in. Remember, don't be distracted by the question that says run a computer simulation. That's fake data. That's not a real analysis of results. That's not real evidence. On to our last bit from Interim 1. Technological design vocabulary. We have 3 words here. Trade-off. A trade-off is where you're exchanging one thing for another in evaluating its value. What I mean by that is that if you go to a store and you buy a backpack, that's just a trade. You handed someone money, they handed you a backpack. But if you decide, I have this backpack for $30, but I can buy a shark backpack for $38. Do I buy the shark backpack because it looks cooler? Now, maybe I buy a backpack because it has more pockets, more storage. Whatever the reason is, do you have value for your reason? So a trade-off isn't just buying something. It's buying something because of your decision. Do I buy this one for this price? Or do I buy this one for this price? You're weighing a trade-off. Exchange of value. The next one is the word constraint. A constraint is something that restricts something. So, for instance, I want to make a machine that is going to make me breakfast every morning, but if it's going to cost me tens of thousands of dollars, I don't think I can really afford doing that. So a constraint is anything that limits your ability to make something or limits a solution. So, for instance, when we do our testing, I might say your constraint is you can't use a calculator on this problem. That's a constraint. It is a limitation. Troubleshooting is our last one. Troubleshooting means that you're testing something to try to figure out where the trouble problems are. You're trying to figure out what is wrong so that you can fix something. Thank you so much for watching the video. I hope this does great things for you when it comes to the questions about the first interim. Go on to check interim number 2 video if you want to work on the second page of the packet. Adios, everybody. Bye.